Okay, so welcome to the first lecture of cloud computing. So it's also my first time here in this lecture hall. So we were here a week back to investigate how to do a lecture here. And probably that is also a bit the reason that not everybody found the lecture or decided it's too complicated. So we have many more people registered for the lecture. 430 are registered. And there are also some on the waiting list. I would definitely like to give also them a chance, but we have to manage the exam afterwards, right? So that is a big challenge since we have no tutor groups or so, tutors that help in correcting the exam. So we will do it together, and so our capacity is also limited, and there are also these, for me, strange rules of the university and the faculty about using multiple choice questions. So the automation of the exam is also a bit difficult, right? So anyway, so let me start introducing a little bit who is giving this lecture. So it's myself, of course. And then we have Shashalin Benedict, a colleague from the IIIT in Kottayam. He's collaborating with us in a long time now. And he's this semester also a guest professor here at the Technical University. And he gives a class on IoT. I advertised this to you. You all should have heard about that. So initially the class was announced to be, it's 3 hours and 1 hour on Tuesday from 8 to 9 and then 2 hours on Thursday. And we now decided to actually move these 3 hours together. So we have a 2 hour slot on Thursday. And so everybody who is interested is welcome. There are still seats available. I saw that some additional people registered, so it was a bit of problem of the announcement of this lecture, that it was not very clear what it will be about. So if anyone is interested, please also spread the word and advertise it a little bit. So we have no lecture on this Thursday for the IoT, but then the next lecture will be next week on Thursday. And in a different room as previously announced. So we had the interim Sursaal 2, which is this black building over there. And we will now switch into a smaller room because it was a small group in mechanical engineering building. Good, so that's Shashalin Benedict, and he's working also on research in the direction of IoT and cloud computing at the IIIT in Kottayam. So, and then we have George Cardoso, who is head research of a group at Huawei here in Munich, at the research center of Huawei here in Munich, in cloud computing and related technology. So he's also professor at the University of Coimbra, and also with Huawei and George we have also a long-running collaboration now. And he will talk about OpenStack, so an open source cloud infrastructure. So, myself, I studied in Bonn and did my PhD thesis on automatic parallelization for distributed memory multiprocessors. So, you might know that our share is heavily involved in high performance computing, and so at this time, so that was 89, I finished the dissertation, but until then basically we had as supercomputers these Cray vector machines, so a few vector processors, and then by the time when I finished my studies, actually the massively parallel systems came up, so that you have not that powerful processors, but you have standard processors and you combine a lot of them, right? And you all know, I hope at least, that this is the way HPC systems are currently structured, right? So if you go for LSZ, you have, what is the name of this machine there? No one who knows how the supercomputer at LSZ is called? Wow, so we have to do a bit more public relations, looks like. Huh? No, it's Superbook NG, so Superbook. No? So, and this is a perfect example of the standard architectures that we now use for high performance computing, right? And this started at the time when I did my PhD work, and these are called distributed memory processors because the memory, the central memory that you know from your laptop or so is basically distributed over the nodes, no? And so we worked on automatic parization. That means how to split up applications and distribute them on such an architecture. So, and then I went to Vienna, and we basically continued the work. And from there, I became a research scientist at the Forschungszentrum in Jülich. So there are a few large-scale research centers in Germany. Most commonly, they started actually in nuclear research, but then they diversified and have now basically a wide spectrum of research activities. Here in Munich, we also have one. Who knows what this is? In Neuherberg? Yes, the Helmholtz Centrum, right. And so they belong now together, these centers, in the Helmholtz organization, and the Forschungszentrum Jülich, which is actually in the west near to Cologne, between Cologne and Aachen. This area is known for Braunkohle, so coal that you basically, you don't dig deeply, but you can dig it on the surface and it's burned to make electrical energy, and that is obviously nowadays no longer a good and accepted strategy. So, but that is Jülich known for, and the research center did nuclear research, but then also a part actually is a Jülich supercomputing center. So they always had, even before I joined there, the HPC machines, the most powerful machines in Germany, and they still continue to do so. So compared to LRZ, they have bigger and faster machines. But in Germany, obviously, we have the strategy to distribute such research money and research tools so that we can educate and give the opportunity to many people spread out here in Germany to access and do their simulation runs. No? So and then in 2000 I joined TOM, and here basically I continued working on high performance architectures, mainly on tools for that, so performance analysis and tuning, right? So you have these machines to compute fast, so you should actually also carefully use them, right? And so you need tools to understand why the performance may be not that great as it should be. And so this, we developed here such a tool, and which in contrast to many other tools did this automatically. And then you also try to tune your application so to make it run faster basically. And so that was in the center of the Periscope project. And since a few years now, I switched over to cloud computing, and we are focusing on several topics here, so IoT as well as function as a service, and you will learn much more about that during the lecture. We will also present to you our own environment called the Function Delivery Network. And so that is, in the heart of the lecture, what we are currently doing. So you can reach me, preferred by email, but obviously more probably you contact mainly Anshul and Mohak via Piazza, or what it's called.
Piazza.
Yeah. And so you basically put your questions there, but if anything is urgent and you think you want to talk to me, please do so. So the content of the lecture, we start with an introduction today, and next week we talk about the base technologies. So yeah, the enabling technologies for cloud computing. Then this covers then in the third lecture virtualization as the main topic, but we also learn about computer architecture, networks, and data centers. So this is basically what the hardware is for cloud technologies, right? And then we look over a few lectures into infrastructure as a service. So we learn about the concepts, especially on Amazon, and then the cloud storage, OpenStack, as I said, is open infrastructure, or infrastructure for cloud computing. We talk about monitoring and auto-scaling, so techniques to actually observe what is going on the cloud, which is, for example, necessary to actually send you the bill afterwards for using the cloud. No? And auto-scaling means that you automatically support the scaling of the hardware, the resources for applications according to the current usage of the applications. And then we switch over to platform as a service. And so this is, in the focus are platforms that support microservice applications. And clearly there is one very important platform, it's Kubernetes. And so we will look into that. But also Azure, for example, Microsoft Azure is sort of a main driver behind platform as a service from the very beginning of cloud computing. So we also look at what the offers at Microsoft are. And then on top of that, we go then into function as a service. And you basically, this is always a higher level of using the cloud. And then we talk about the function delivery networks that I already mentioned, our own research work in that direction, and then a lecture on the Internet of Things. Good. With respect to the organization, so the lecture is on Tuesday from 1:45 to 4 o'clock. So we have actually a longer slot because we have 2 lecture hours and 1 exercise hour, right? So this will not always be used, the exercise hour, but from time to time, and you can see in Moodle whether there will be an exercise or not. So in the exercise slot, the upcoming exercises are presented, the solutions for the previous exercises, and then you have a bit of time, so like 2 weeks, for example, to actually do the exercises. So then we have the Moodle course, and we publish the slides there before the lecture, but not much before the lecture, because typically we go over the slides on the same day again, and there might be little tweaks here. And but we upload it definitely before the lecture, so if you want, you could download and take notes or so on the PDF file. Then there are recordings, so we record the lecture. That is only what I want to say is we cannot guarantee that it always works, so I have to push quite some buttons here, and if I do it wrong, then you might get only the video stream, which does not help much. Then you have only the slides, but if I do it correct, then you also get the sound. And then we publish this on Panopto, and you can access it from there via Moodle. Good. In Moodle, there's also sort of the precise schedule as we can foresee it, how we progress through the material. and what is planned for the exercises. So that gives you a bit of an impression, what will happen in the next meeting. So the exercises are run by Anshul Jindal and together with Mohak, and they will talk a little bit more after my part about what will happen in the exercises. So we start really with the first exercise in the next week. And these exercises are really hands-on, so you always have to do coding, managing your infrastructure, and so on, right? So you have to create virtual machines in the cloud and put your software there and all that stuff. So it's really targeting more the computer science students that have a bit of background and can do that. So I know I have also many here in the class that are not computer science. So you might have a bit more challenges here, but nevertheless, so you get really a hands-on experience with using these cloud technologies. That's the idea. You do it in groups, and you have about 2 to 3 weeks time for each exercise to do it. And then there is a way to automatically check that you basically succeeded. And so that is, Anshul will tell more about that. So the assignments cover quite a spectrum of things. So from Node.js programming over container technology, microservice architecture, to function as a service, so everything will be there, and probably you will need the time to actually do it also, the 2 to 3 weeks, and I hope you will enjoy, because you actually will learn a lot by running the exercises. So there is a bonus of 0.3 in case you did the exercises and did them successfully. And you will also learn a bit more about that from Anshul. Okay, so over there are plenty of seats. Good. Any questions to the organization? Yeah, please.
An error that lectures on Tuesday is...
That's an error. Right. So that is actually a misunderstanding from my side. I believed for a long time that the lecture will be on Tuesday, but it's actually on Wednesday. We had discussions about the room, and they offered Tuesday and Wednesday. I remember, and I said Tuesday because it was always on Tuesday. But I got Wednesday, so I did notice this only very late. So, and it didn't make it here on the slide. So thank you. Good. Any other comments? Yeah.
So the groups are groups of 2, but only one person uploads the assignments, or do people have to upload them individually?
No. Only one submission is there, a group submission. Okay, but about the exercises, maybe you ask later, because Anshul has some slides, introduce a bit more in detail what we do and how you actually submit and so on. So maybe then we can come back to that. Okay, good. So then let me continue. Next important point is the exam. So, come in. And there are many free seats over there. So, the exam is planned as an online exam. I had very good experience with Proctorio, actually. So if it will be offered, I'm not sure about that. But if it will be offered, I will use that for the exam. So for those that don't know Proctorio, it's basically an environment where the exam is run in Moodle. It's a Moodle quiz. Maybe you experienced Moodle quizzes already, right? But you are observed by your computer. So it basically enforces that only this one window, the browser window, is open. You cannot do anything else. The mic is on, the camera is on, and it automatically records everything. And then we have 2 weeks time to actually check these recordings. The environment marks suspicious events automatically, and so we then together go over these immediately after the lecture and make sure that there's no cheating. So you can actually do it at home. Yeah, that's a big advantage. We also offer an on-site version at the same time. You still do it with Moodle, but there will not be this proctoring by the software, right? Only enforces that you cannot go to the internet and so on. These things are done, but there's no proctoring. So we have to offer both, and that worked very well. So we had only very few students to come to the on-site event. So it seems also to meet the interest of the students. Yeah. But if you are concerned about your privacy and so on, so you are welcome to then to come to the lecture hall and take the exam there. But honestly, I'm not sure that this will be available this semester as well. Yeah, it was introduced because of Corona. Now at the moment we all ignore Corona. We have other challenges, right? And so I don't know. Yeah, what the status will be. Otherwise, we have a normal exam, paper exam, right? So, it includes free text question, multiple choice, and probably other question types that you'll find in Moodle in the quizzes. Yeah, so there, maybe you have seen that you can fill in names into boxes, for example, and all that stuff. So it's quite nice. And so we use this successfully. We have a nice collection of questions already. So that would be our preferred choice. If we are allowed to do that, we will do that. So there will be no repetition exam this semester. There is a repetition exam next semester, at the end of next semester. So I want you to participate in this exam, right? If you have a choice to decide between two exams, you go for my exam and maybe to the repetition exam of the colleague. So, this is important that it's on the slide. You know about that and are aware of. Good. Any questions to the exam? No. Okay, good. Then I have this slide here. Looking at the feedbacks that we get from students, you have to understand it's not a sort of business-oriented lecture about cloud computing. We are from a computer architecture share, so we are very much into hardware and operating software and so on. So that is the focus of the lecture, right? So, and if you feel like after two lectures this is not the right material for you, then it will actually maybe get even a bit deeper in the run. Yeah. So then, please also deregister into online. Yeah, because then we can give these free seats to other students that currently did not get one. I have a waiting list, and there are obviously also more that just registered and did not get a fixed place yet. So I would be happy to actually distribute free slots to other people. So it's up to you. Please follow the course, and if it does not match your expectations, please deregister, and then everything can go smoothly. Okay, so most important sources of information. We don't use a book for this lecture. Basically, these are different chapters that we collected according to what we think is important in this field. It's a very dynamic area of computer science, so lots of new things pop up every year, you could say, and the focus of research moves from one level, for example, virtual machines, to containers and so on. So we try to update the material as needed and use mainly the online documentation from cloud providers or tutorials, hand-on information, but also obviously research papers. For that, there you find also information in Wikipedia and so on about cloud computing and the related services. Books as well, and I have on the next slide, I have 3 books that I like to read, but these are not actually the basis of certain parts of the lecture in that sense. So if you want to look for more information, you have to search it by yourself, right? And look into the net. So it's this book from Bofmik on cloud computing. Then we have another book here which I found interesting about concepts, technologies, and architectures. And there is a third one about cloud native architectures, so that actually you basically develop software so that it's specifically written to run in the cloud. So definitely also an interesting book and really worthwhile to look into. Good. So then I would go a bit into the real material. So let me start with the current, let's say, IT trends. So the first one is outsourcing. So that is not a very recent trend, but it's clearly a trend, so that companies actually don't run the IT infrastructure on premise, in their own buildings, for example. And so the first step towards actually getting rid of the real infrastructure, so the physical servers, you can say, right, was outsourcing. So companies like IBM offered this, so that other companies like MTU, for example, they go to IBM and say, you run a compute center for us, but you do it please on my location, because my data are very valuable, and I want also to have this physical security that comes with the MTU area, so they have a fence around this and security personnel and so on. So the compute center is still on this place, but the operation of the center is given to IBM. Right, so that is called outsourcing, and IBM would be responsible to set up the servers and so on and so on. So the next one trend is re-centralization. So at the very beginning of computers, they were really central, and so these were big machines that were in a compute center, and you had to go there. Maybe you heard the stories about the punch cards, right? You had a desk of punch cards, one card after the other. You gave the cards to the operator, and the operator let it go into your cards, and then the program was executed. It could do only one program, but so it was sort of time shared between the different users of this computer, and in the interface were the operators. So that was really very centralized, no? And then we all enjoyed when PCs came up that you get your personal computer, right? So that is also long ago, but we had a distribution of computation. Everybody has its own computer, and so then after that we see the trend of re-centralization, so that actually instead of giving a laptop or a desktop system to everybody, we have, for example, remote desktops, right? These are virtual machines or so that run on a central server, and you can log in from whatever screen you have, and you will find your desktop again. And so by this re-centralization, definitely, I mean, you centralize also the knowledge about the management of the machines. You reduce the efforts that you have to put into updating all these little systems there, and so that is definitely also such a trend in IT. So another one which goes a bit again back into the distribution direction. So you all heard about IoT, right? That we connect devices to the internet. And so that means that we basically measure, for example, the temperature here over the campus in all the rooms, and we send the measurements to the cloud and store it on a central place. So, that would be cloud computing, but nowadays actually we go also into the direction to distribute the computing of this data in the sense that we actually place little machines on the edge of the network. So these edge computers are sort of near to the sensors and actuators. Yeah, so if you, for example, BMW has a place where they fabricate the cars, right? Then maybe for the control of the robots, you have to immediately tell the robot to stop when there is a difficult situation, a security problem. Yeah? And you cannot wait until the data of the sensors go to the cloud, are processed there, then the information comes back, and the robot is stopped. Yeah? And so that is the idea of edge computing that, for example, to reduce the latency as described in this example, you actually place a bit compute power near to these sensors. So we distribute compute power again. Yeah? So computing is always about centralizing, distributing. In HPC, it's actually the same. Yeah? So we have shared and distributed memory, and it goes back and forth there. Resource sharing instead of over-provisioning. So that is obviously in the interest of companies, right, to reduce costs. So, and it goes hand in hand with what is called server consolidation. So server consolidation means that in a company you have a lot of servers, and typically for an application you have your own server for that. Yeah? And simply to ensure that it meets your requirements of latency and so on. You don't want to share it, maybe also for security reasons, you have an own server. So there are lots of servers out there, right? And these servers are working only on a low usage level. So the load level would maybe only be 10% because only one application is running there. So that is very expensive. Yeah, you have an own server and you don't use it efficiently. And therefore, the compute center started with server consolidation so that actually these servers are virtualized. So you have one physical server and then you get your own server, but it's only a virtual server anymore. Yeah, and by now putting multiple of these virtual servers on one physical server, you can much better utilize the hardware for which you actually pay quite a bit of money. And so that is now, also related to this, to what is written before, resource sharing instead of over-provisioning, right? Over-provisioning means that you provide much more resources than actually are needed. Yeah? And here, resource sharing means we share the physical resource and we still get the same service level, but we don't have to put so many machines out there. Then another trend is green computing. Maybe I always forget, I have to look it up, but the data centers actually take a considerable amount of electrical energy nowadays. And so it's very important to actually reduce this energy consumption. And I might come back in the base technology next week to that, because LRZ is actually one of the highlights here that really improves on the usage of the electrical energy going into this whole infrastructure that they run. So green computing to reduce the amount of energy used for computing, and this is now going also into carbon efficient computing, so where it's not only about the total energy, but you actually try to use green energies. Yeah, so you want to use energy from wind turbines instead of energy from coal produced from coal, so brown energy. And that means that you actually would, for example, move computation to a certain country only because it's very windy, right? So the computation would actually follow the availability of green energy. A big problem is you cannot easily store green energy, right? So you have to use it. And so in some cases, computing is really an easy thing to migrate. It's much more difficult to migrate a steel plant or so. That you cannot do on a short notice, but computation you might be able to do. So carbon efficient computing is the point here. Then scalable computing, so we are just using a single computer, we are using parallel computers. The demand for computation is extremely high. We collect more and more data. To process the data, you need really scalable processing capability, and so something like LSAT, for example, falls in this category here. Application dynamism, also common nowadays. So in former times, you had an application and you run it on a machine, and it always takes the same amount of time, and that's it, right? Nowadays it's different. You have customers out there in the world and they actually order products. And depending on when people are active in China, for example, a huge demand will be in that period of the day for your e-commerce company, right? If everybody is sleeping, probably not. So it's highly dynamic, the load, and so we have to find ways to handle this. Big data, I spoke about big data already. Machine learning is clearly a trend. I don't speak about machine learning here. Stream processing is also important, especially in the context of IoT, so that you have streams of data and you want to identify anomalies, for example, in such a stream of data, or video processing. All that falls under the category stream processing. IoT, mobile computing, obviously, we all are used to mobile devices nowadays, and not only compute on the desktop, but we want to have access to our data and to the services that we need all the time, and do it through special networks, for example. And I talk about these networks later as well. And then another trend, so there are many trends, autonomous computing. So autonomous computing basically means that the systems are, for example, self-healing. So if there is a problem, the system can automatically recover from that. And that is a very important aspect of cloud computing, because cloud computing is actually about I can get resources on demand, right? And that only works if you do it in a large scale, if this management of the resources is automatic. Right? So we need autonomous computing. This buzzword started also probably 15 years back, but it's now a very important concept for running cloud data centers. So what is cloud computing? So cloud computing is basically that you have access to IT services over the internet. So you don't have them on-premise, you don't go to your computer and physically work on that, but it can be everywhere, and you simply log in from remote or use services that run on a machine that is somewhere on the world. You don't really care where it is. And so what is IT as a service? So basically it expands the traditional e-commerce in the internet to IT structures. We are all used to e-commerce, right? We buy more in online shops than actually in real shops anymore. And so the same happens here for IT resources. So you basically go to an internet shop and you buy compute time on a server, right? It's no longer necessary to buy the hardware somewhere. So we expand this model to IT structures. And basically, you rent from a virtual storefront the basic necessities to run your own data center. You can compose without really putting up some physical stuff, compose an own data center that can run your applications. So what are these resources? So it's compute time, of course, also servers, then memory, obviously storage, important, and networking. All that belongs to these resources that you actually need. Then you also rent typically services, right? So these can be applications, special applications running on machines. It can be databases. So instead of setting up your own database, you get a share of an existing database. You can put your data there. Yeah. So resources, also these services cover not only such base services for your applications, but also, for example, authentication. Yeah, so there is a service that actually you register with and which will take care of the authentication of users of your application. Yeah, so messaging, all that can be services. It's a long list, and if you go to Amazon and on one of the very first pages you see a list of their services, it's really impressive. So then it can be applications. You have a fluid dynamic simulation tool, and you basically put this on the cloud or get access by simply registering with a provider. This can also be, of course, self-developed applications. So another important thing is pay-per-use. So you pay only what you at the moment actually have rented, yeah, and not for some reservation or so. Yeah. So scalability. So if you need more, you simply allocate more, you rent more. And you profit from economy of scale. What does this mean? These cloud providers not buy one server, but they buy maybe 100 servers. Yeah? And so they get a cheaper price. And you hopefully profit from that as well, because the services of the cloud provider can be cheaper than maybe if you have to go and buy one server by yourself and you get a bad price for that. So that is the economy of scale, and it can also be that actually there are larger machines bought, and if these machines are larger, they might actually be cheaper with respect to the compute time, for example, because there is some shared infrastructure inside of this server that is then available to more programs running. Enable environmental sustainability. Also, instead of putting your servers here into a Munich data center and you have to cool them down with producing cold water, you can actually put the data center maybe in Iceland. There it's cold, and lots of data centers go there, and so they don't need electrical energy for the cooling of the machines. So, backing data centers can be optimized for efficient utilization and can be built at appropriate places. Right. So, we distinguish several service models of the cloud. And so that is what you initially have, right? So you have your own IT. And so it is, we can think of a stack here, right? So it starts with the infrastructure. These are the physical servers and networks and whatever is there, right? On top of that, you have sort of execution environment, let's say, with some services that actually your application would be built on top of that. Then you have the application here, right? And then obviously on top of that you have also the data of your application. Yeah? So, and everything is on-premise in your own data center. Okay, so now the first service model of the cloud is infrastructure as a service. And that means that only this infrastructure is provided in the fashion of IT as a service. So you can rent servers, you can rent networks, you can rent other physical resources. You don't get the physical ones, but your virtual ones. But you basically, instead of having your own infrastructure, the infrastructure is now somewhere in a data center of Google, Azure, whatever. So the other layers are still there, right? And this is the first step in cloud computing. So what Amazon basically is a pioneer here. Amazon Web Services are therefore a good example of that. Alibaba in China has basically the same offering. Then we have OpenStack here mentioned because this is this open source infrastructure to set up your own cloud. No? It's also providing the services to manage resources and give resources to customers. So the second model is the platform as a service. And here you see that in addition to the infrastructure, also these services and the execution environment for your application is no longer handled by yourself, but it's handled by the cloud provider. And so application logic and data are still there. Very famous from the very beginning in this field, platform as a service was Windows Azure, but also Google Application Engine. And this is definitely where most of the cloud offers now belong to. So I think you hardly find a cloud provider that only offers infrastructure. They also offer lots of services around this, maybe higher level interfaces to run applications on their infrastructure. So I think all of them now belong here. So we could also put Amazon Web Services over here. Yeah. And finally, we have software as a service, and software as a service means you also put the software into the cloud, and then you are just only responsible for your data anymore. Yeah, so this is Salesforce.com was one of the first ones in that direction. So they offer what we know as SAP, right? So customer management, business management, right? And so it was offered as a cloud service, right? So you basically register with them, and then you can use it to manage your processes in your business. No? And SAP is going the same direction. So there are also these Google apps, for example. These are software as a service. They run in the cloud, and you access them. There, Microsoft 365 belongs into that category, Dropbox and whatever is out there, right? So there are lots of such software that you basically use from your client machine. So these are the service models, yeah? And remember the name, service model, cloud service model, infrastructure, platform, and software as a service. So what are a bit the technologies that are used in these three service offers? So what we offer are server, storage, and networking, and then it's in the technologies. It's definitely commodity hardware. So they don't have specialized hardware, not very special expensive hardware like LRZ running a supercomputer. So you don't find this there. These are classical standard racks that everybody needs, right? Commodity hardware, that is how these data centers are actually built. And then the really important technology is virtualization for servers, for storage, networks. Everything is virtualized. So if you allocate a disk, it will be a virtual disk, right? So that it's not a physical disk at all. Server template technology is used to bind the hardware and the OS together. Yeah, you say, okay, I have a template with certain hardware capabilities running Ubuntu, for example, or Windows. Automated management of the infrastructure for self-service of customers. As I said, it's very important because otherwise you cannot handle the demand and the scalability of applications. So dynamic provisioning of physical resources is important, management of virtual resources, optimization of utilization, power efficiency, and also high reliability. And guaranteed SLAs are here in this area. So that is okay. Platform as a service. The offer is basically an application infrastructure, application infrastructure services. These can be managed services, like there is a database. Yeah, it's run by the cloud provider. You register, you get a certain amount of space there. You get also a certain bandwidth in and out, and for that you pay, right? But the whole management of the database is done by the cloud provider. You don't have to do this stuff, and it facilitates quite a bit your life, because you don't have to set it up on a physical server anymore. Then execution environments like Kubernetes or so are there. It might be integrated with development platforms. Yeah, so like what Microsoft offers, you can deploy your microservices directly into the cloud from your platform running on your computer, and so on. And so in that area also I would place the concept of serverless computing. So that is what people currently are going for. So you actually don't worry anymore about the servers. So as this is the responsibility of the cloud providers. Yeah, and you just focus on your application. You develop your microservices or the functions that you want to run. How they are run, you don't care, right? So, technologies here, service-oriented architecture is a very important base technology. You all know about, right? So that is that you have services that have a defined interface, maybe REST nowadays, and you can use these services by this interface. So then we have backend services that can be used in your application, so like a database, authentication service, and so on. We have scalable application middlewares and databases, file systems. We have maybe special programming models and interfaces. And there is typically also support for automatic scaling of the application, as well as support for version management. And here are some examples. Microsoft Azure, I mentioned already the service, Microservice Fabric, function as a service at Amazon Lambda, and the Google Application Engine would be examples for platform as a service. And then software as a service. So these are consumer or industrial applications, and they are run in the cloud. They actually are based on the idea of auto-scaling. The more people actually use it and the more load is there, the resources and everything is scaled automatically. Multi-tenancy is important. These applications can handle different users, one instance of the application, and you typically have a broad spectrum of user interfaces to access these applications. And I mentioned already these examples from Salesforce, Google, Dropbox, and so on. So, besides the service models, we have deployment models, and that is now specifying where the cloud is actually the resources are deployed. And there we distinguish between the public cloud. So that means that is a cloud offering like Amazon, for example, it's a public cloud. Everybody can register, use the resources. Okay, so that's a public cloud, the first deployment model. The second one is a community cloud. That is a cloud that is run for a certain community. So, for example, the US, for the intelligence agencies and any federal administrations, they run their own cloud. It's a cloud system, but it's only accessible for this community. Then we have the private cloud, and the private cloud is also quite interesting. So companies actually, so they have a lot of servers and they want to benefit from cloud computing, but they don't want to actually externalize the resources. So they only manage their existing resources with the help of cloud software. So you put OpenStack, for example, on top of that, and then all the people in the company can actually dynamically create new servers. So who knows example here at our campus, at LRZ actually, that is a private cloud. Yeah?
RBG.
RBG. I come back to RBG. No, I don't. This is, yeah, not a cloud. The LRZ has a cloud. The compute cloud, right? So the LRZ compute cloud, it's really a cloud system, so you can dynamically allocate servers there. And they are hosted on a cluster that is physically located in LRZ. Yeah, that is a very classical example for a private cloud. And the RBGs that you mentioned, they also manage virtual machines. They run VMware, and you can get virtual machines, but it's not self-service. So you have to call the RBG and say, oh, I need another server, please, yeah, and then they will do that for you. So it's not cloud computing, right? Cloud computing would be self-service. So you go to an interface, say, oh, I need a new virtual machine, and bloop, there is it. Yeah? That is not what RBG offers. That is what LRZ Compute Cloud is about. Yeah? So if you have an account at the LRZ Compute Cloud, you can run up to 4 virtual machines. Good, and then there is hybrid cloud, also a term that is frequently used, and there's quite a bit of interest in that, so that you actually combine private and public cloud together. So that might be for the purpose that you want to protect your data. So they go to the private cloud, while other data that are not that critical you put maybe in the public cloud. Yeah, so there is always a fear a little bit in the public cloud, data might not be that secure and so on. So and companies are sensitive to that. So they might actually use both words here and combine it. Another example would be that you use it as an overflow for your computation. Yeah, as long as you can run your computation on your own servers, you do that because you already paid for these servers, right? But if this capacity is no longer sufficient in special time, then you actually use the cloud for that. Yeah, it's an overflow of the computation into the cloud. And so these 4 are the major deployment models. There are also variations about that, but let's not talk about. Remember these names: public cloud, private cloud, hybrid. That is what you find very frequently in articles and so on. The community cloud is not such a prominent term actually. So then I have here a list of I copied parts of the definition of what cloud computing is from the NIST, that is the National Institute of Standards and Technology. There is a special publication, and there you find these definitions. So I think we don't have to read it here because I explained what cloud computing is. But you should definitely read it by yourself. Yeah, so it is really giving a more clearer definition what we mean by cloud computing. So they define cloud computing here, and then they define essential characteristics. And there is on-demand self-service. I explained that. Yeah, so RBG is not a cloud, while LRZ is a cloud. Yeah, it's on-demand self-service. You have broad network access. In addition, so broad network access we had years back to computers, right? But it was not cloud computing. Yeah, but that is one of the essential characteristics, that you can access these services that you use through a network via different platforms. Resource pooling is an essential characteristic. So you put together lots of resources and these are shared among all these people that rent virtual machines, for example. Yeah. And we have rapid elasticity. That means that when your application demand changes, the set of resources available to the application can dynamically very fast be changed and adapted. So, finally, the fifth one is it's a measured service. So we actually keep track of how much is used of the service, and that is the basis for your payment. Then they define the service models, and I also explained this already. Software as a service here, that you basically access the software in the cloud through different client interfaces. And there is a little bit of configuration might be there, but you don't configure any servers anymore and so on. All that is hidden from you. You might be able to set configurations for the software, but not for the lower layers that are basically there to implement the service. Platform as a service, we also talked already about that. And then infrastructure as a service as a origin of cloud computing, so that really hardware is virtualized and given out. You manage your own hardware. No? Okay, so let's look at the summary table here. So these are the cloud technologies that are used in the different service models. We have there on the top is the service model, infrastructure, platform, and software as a service. And then we have the service category. So that is VM rental, online storage, and so on. So that is offered in infrastructure as a service. Online operating environment is platform as a service. And then the service here is actually that the application of the software is offered. How can you customize the services? So here we have the server template. I mentioned this, that was this combination of operating system and hardware. Maybe also that there can be also application components integrated already. Then here you basically configure the logic resource. For example, you can set up the database or the new portion of the database, and can say how many replicas you actually want to have of your data to service a certain read demand. And on that side, it's the application configuration, application parameters. No? So then we have service provisioning here. So that is definitely automatic. Everywhere it's automatic. That's what we want. Yes, you don't call someone, please give me a server. Access and usage. For infrastructure as a service, they offer web interfaces to manage your infrastructure, right? So you get a nice web page, and there you can say, oh, I want a new virtual machine. You specify what you want. There is also a console typically available where you can do the same by commands. And there are REST interfaces. So you can write programs that call these REST interfaces, and by that you define your infrastructure. In platform as a service, basically it's online development and debugging, but it can also be offline, so that you actually have development tools to develop your microservice application and deploy it on this infrastructure. That is a common way to actually use such platforms. Typically you also have web interfaces, especially for monitoring Kubernetes, for example. You have a nice web interface, you can see all the containers running and so on, and inspect what they are doing. So that should also probably be mentioned here. And for the applications, you can use your browser sometimes. They have just a web interface, but they can also have REST interfaces to access the application, or sometimes you have SDKs that allow you to develop some client software that uses an application of the cloud provider. Yeah. So that is the first part, and the second part, there is one more slide with this. So for the monitoring, to observe what's going on, no? So you basically monitor the physical resources in the infrastructure as a service. Here you monitor the logical resources, and here you monitor the applications. Service level management, that is based on dynamic orchestration of physical resources. So you decide how to put together physical resources to actually provide the service. Here it's about logical resources, and here it's about the applications. Service accounting is basically by metering, physical metering, so you measure how much load is on the machines and you distribute it. You look at maybe how much network traffic is there per virtual machine running on the physical machine. So you meter basically on the hardware level, but you map it back to these virtual servers that are running there. Then we have here the metering of the databases, for example, and here we have the metering of the application usage, so how heavily you use certain components, for example, of the application. And security, here we have things like isolation, so that you run virtual machine hypervisors that isolate the virtual machines from each other and give some protection of the computation inside. There is also storage encryption in hardware. There are these in the networks, you have VLANs and so on, and firewalls and all that stuff that you manage basically to secure your infrastructure. Here it's basically about the isolation provided by the platform. So like multiple containers running there, so they have to be isolated. And here it's basically that the data have to be protected and that the access to the software is protected, and clearly then only also authentication authorization has to be managed. That obviously should also be in the other service models. Good. Here is a comparison between what I explained, outsourcing and cloud and internal IT. So look at the capital investment. That is a very important, always mentioned aspect for cloud computing. You have not to do capital investment, right? So you don't buy first a server and then run something there. No, only when you have something to run, you rent the server. So capital investment in internal IT is significant. In outsourcing, it's moderate. So you have typically a base setup fee, and then also depending on the usage maybe. And in cloud, everything is basically pay per usage. Ongoing costs, internal IT, I would, it's moderate set here, but I would actually say this is high. Yeah, so you have to not only you have to pay for the hardware software that is in the capital investment, but then you have also to have hire people that can manage this hardware and the operating systems and so on and so on. So I think the internal IT actually has a high ongoing cost. In outsourcing, you have a contract with IBM. It will not be cheap, so there is also considerably payment, and in the cloud it's based on the usage. So if you have times where you don't need so much hardware, then you can actually save costs, and that is a big advantage of cloud computing. So provisioning time, definitely significant internal IT. So at the moment, if you want to buy a laptop at TUM, it takes 3 months or so until you get it. So there is really a long time, So, and if you want to have bigger machines, you actually have to get multiple offers and all that stuff from companies. So it really takes a very long time. So moderate here because you have a contract with someone who is maybe having more servers available and might be able to dedicate one of these hardware servers to you as well. And in the cloud, it's none, right? So it's instantaneous. So that is what we want. You just type a command and you get your server. So flexibility is definitely also here in the cloud very high. Yeah. Staff experience. So it's said significant here, clearly. Here it's limited. Your own staff, yeah, you because you give responsibility for the hardware to this outsourcing company, to the companies that will manage it, you don't have to have this knowledge anymore. Yeah. So there it's actually you reduce the staff experience, which may be good or bad, no? And then in the cloud, it said moderate here. I personally would say, yeah, in some areas you don't have to have so much experience, yeah, how to run physically your servers and so on. So that is something that is a cloud provider responsible for. But you still, if you have infrastructure as a service, you have to have the virtual servers, you have to know how to set up the networks around it and so on. So that is not negligible here, but what you need an experience to actually run something in the cloud, and so you have a chance to learn a little bit the skills that are needed. Reliability depends on how you manage your hardware. Here it's high because there are these experts responsible for it. They can have also replacement servers and so on. But that is also a big advantage of the cloud because they have this huge infrastructure. Yeah, so if one server breaks, they simply move your stuff to another one. Privacy is seen to be a high here. Yeah, so because you have everything in your hand, you can control it. You don't have to give the data away. Here it's moderate, and here it says no, because the data go outside under the control of someone else, right? And then you have security, moderate, high, and here it's also saying moderate. But actually, I would say this is also like in the outsourcing here, because Amazon basically develops all these techniques that are necessary for protecting the machines and your account and so on. But still, you have to use it in the right way, right? So maybe if your personnel is not well trained in that, and the setup for your application is not very good, it might be actually lower, right? But it's basically the same here. So if you don't have the well-trained personnel, here you can expect that you actually have special people from IBM or whatever, the T-Systems, to take care of these things. Yeah, login is low here because you can at any time take decision to take another server. Moderate here because it depends, yeah, so you are somehow bound to the management of your infrastructure to this company. And here it's currently high because all these cloud providers, they don't provide you with portability. They are interested to get your applications running on their machines, and not that you are able to move to Azure or to Google or so. Yeah, there are some third-party offerings that simplify this, and like Terraform, for example, and we will learn about that also here in the class. Then, good. Applications. So these are sort of some of the very early applications running in the cloud. So the first one is showing more HPC usage. So it's about drug discovery for maybe personal medicine or so. And it's a company, Eli Lilly, that used this. And the advantage that they had from using the cloud for these HPC computations, yeah, you actually do simulations, you try to find the right medical parts that actually can attack the disease or so, yeah, this special disease. And so you have to do simulations, it's quite compute intensive, But if you have only one cluster, maybe the cluster is used by other people, right? So you cannot immediately run it. If you have the cloud, you simply put it in the cloud, there are enough resources, you run it there and it's done, right? So that is the advantage here. Second is the New York Times. It's about data conversion, so they had a big library of old articles and they wanted to transform it into new data formats, and they did this through Amazon. Yeah, it's a one-step process basically, and so instead of buying machines to actually do this conversion, you put it simply in the cloud. Yeah, and you rent the machines only for that purpose, and then it's done, and you don't have to pay anything more. Finally, we have here is Pitney Bowes. It's a B2B application, business to business. It's a hosting model for mail printing. I'm not sure that this is still relevant, but clients could basically, looks like, print their emails there, and based on Microsoft Azure and SQL, so a database, and so their advantage was that there is a higher flexibility at a lower cost and a new business opportunity to offer something to other customers. So I have one more let's go back here. So I think for all these use cases, at least for the first two, it's clearly that you have a spontaneous demand for compute power, and that is serviced by the cloud. So that is a very important aspect for the cloud. The other one here, down here, sounds to me a bit like that you have a more continuous demand, but it depends on how many customers do want mail printing at this moment. But if you have a continuous demand, it might be cheaper to set up your own resources instead of buying them from Amazon. No? So here is another use case, the Animoto story, and the company is still around. So what the offer is of Animoto is that they offer the creation of videos from your pictures and your favorite music. So you upload your pictures and you give the music you would like to have, and then they basically create a video from that. That's their business. So, and they had in mid-April 2008, they had about 5,000 users per day. So then there was an article in the New York Times advertising this service, presenting this new service to all the readers of the New York Times. And then it went up to 750,000 new users in 3 days. And so there was a Facebook app. The article is actually describing that, but it's no longer accessible. You have to pay for that. But this was a Facebook advertisement, right? And due to the Facebook advertisement, 750,000 new users in 3 days. So how can you do that if you manage your own servers? It's not possible. You have in 3 days to scale your servers significantly. And the peak was actually 25,000 new users per hour. So that can only work if you have automatic scaling. Yeah, so you don't have to ask someone to put a new server. The software allocates automatically servers that can handle all these new users. No? And so in May 2008, actually, Amazon bought the company because it was so successful usage of cloud computing. Good. So this is from the very early days, actually, of cloud computing. So let's have a quick look at Amazon. Amazon Web Services. We do that in a bit more detail in one of the next lectures. So the offerings one of the important offerings, the first one is EC2, Elastic Compute Cloud. That is infrastructure as a service, so servers that are offered to customers. There is also a storage service, S3, simple storage service, and some others that we probably come back later, so like a content delivery network, a database, and so on, and so on, and so on. So this is the website. So they use for the virtualization So you allocate virtual machines, and these virtual machines might use hardware storage that is actually allocated to the physical machine or on the physical machine, or it can use a block storage, so disks that are not on the physical machine but in a storage area, network, for example. There are virtual firewalls to secure your network, so you put your servers on a virtual network and then you define virtual firewalls for that, and so on. So that is basically how to manage your servers that you allocate and put them together into your own infrastructure. And the virtualization is based on the well-known Xen hypervisor, and they are now also developing their own hypervisors, virtual machine monitors called as well, for special purpose, for higher performance, for the needs in the cloud. And I think we will talk about this a bit more in one of the later lectures by Mohak. So the whole idea of Amazon is that we have data centers, big compute centers like LSF distributed all around the world. These are only a few ones here on the maps. There are many, many more. And you basically can put your servers, you can select in which data center you actually want to place a server. And it might be a good idea to have a copy of your servers in other data centers for reliability. Yeah, if there is a power outage in one data center, your application would not fail. Big advantage from cloud computing. The other one is that you can also distribute your servers with the idea that you service your customers at a special location. For example, if you have customers in Japan, they might have a faster access to the Tokyo data center, while actually your customers in South America down there actually would go for the Sao Paulo, simply the latencies are lower. Yeah? So it really depends on the distance your messages or your traffic has to go. Good. Technology sources of cloud computing. So these are service-oriented architectures. I introduced this. Virtualization, very important, yeah, so that you can place virtual servers on top of the physical servers. But it's not only servers, but also networks, storage, and so on. All that is virtualized. Server consolidation is definitely one of the important technology sources, how to put multiple servers as virtual servers on a physical server, how to manage such settings. So VMware is really a very important provider of technology for server consolidation. Then grid computing, that is the idea of couple high-performance machines all over the world together in a compute grid, like the electricity grid. That is also probably like 15, 20 years back that this was en vogue. And so instead of actually having to go to one physical HPC system, you could actually select from all these HPC systems and get maybe an immediate execution of your application. Yeah, that's grid computing. In contrast to cloud, it's a sort of similar to cloud, but in contrast to cloud, this was always designed as different administrative domains. So we had, as I said, we had Jülich, we have Oregon, we have here and there a supercomputer. This supercomputer is controlled by the institution that has it. And then they collaborate to put up this grid. In cloud computing, it's different because the cloud has only one provider. It's Amazon, it's Google, it's Azure. Yeah, all the resources that you access there belong to this one provider. Yeah, that is a very big difference between grid computing. Grid computing was always about putting together resources from different owners and with different interfaces. It was always about interoperability, and that we don't have in the cloud so much. In the cloud, it's not about interoperability. Yeah. Good. And cluster computing, of course. I talked about the distributed memory machines. And so you put together a large number of machines simply to speed up the computation. That's called cluster computing. And without cluster computing, data centers would not be possible at all. Without this experience from running these clusters to speed up applications. Good. Why going for the cloud? So the pros are economy of scale. It gets cheaper. The scalability that you have for your application, elasticity, scalability on demand. So you can easily react to load changes of the application. Rapid deployment, no capital investment, no caring about the infrastructure. A lot of good reasons for cloud. Limited access to on-premise servers, so there might not be enough servers, so it's a scarce resource, so you might not be able to get it solved by cloud computing. Fault tolerance, because you can replicate application components across this big infrastructure. And obviously collaboration. We all profit from cloud computing in the form of collaboration, right? You can share information, data, computation, everything, and so enabling collaboration. Then the cons are security concerns, maybe rectified or not rectified, controllability, so you cannot control the hardware anymore, so it's limited, no? Vendor lock-in is a problem, so that you are bound to one of the providers. Then there is also a drawback, and that is cost and monthly fees. So, one moment. You don't have initial investment, but you have to pay per compute hour or whatever. And when I talk about Amazon, I show you for what you all pay. I mean, it's quite impressive, So I think this is also considerable costs that you can have with running your application in the cloud. Yes?
Why is the cloud? Or could you explain why it's less secure? What makes it less?
So therefore I mentioned this. So the problem is that you have to, for example, trust into system administrators. So that is something that people are really concerned about. The system administrator can basically access whatever data are on the files in the file system, for example. So there must be means to protect this, and you probably have set up procedures in the cloud that guarantees that not a single administrator can do that or so. But so that there is an audits and so on and so on. So you have the same problem on-premise as well. You have system administrators there, and if they are, you cannot trust in your own system administrators, you might lose data, no? And my personal opinion is that the security actually in the cloud is actually quite good compared to on-premise, because on-premise you have to have experts that know about all these techniques and enforce that they are used and so on. And so in the cloud you have these experts, right? So Amazon has these experts, and they develop all the tools that are necessary. And so from my point of view, actually, I think security is really not less, but people, when you talk about cloud, they really are frightened by putting data into the cloud. So it's simply, I think it's simply that you fear that, whether it's rectified or not, it's not clear, that you fear that the data can more easily migrate from theirs than if it's on-premise. And somehow this might be correct if you think about LRZ, so there is actually a few servers, and around the servers is a physical fence, right? And in these servers you have the data from, for example, the hospitals, right? So there is some physical protection in addition, and that is obviously a bit limited in a cloud data center. You have a big data center and you don't have your physical servers and you don't protect them from the other. Yeah. So yeah, there might be reasons, might not. I'm not really not a security expert here, but from my point of view, I think the advantage is that really there are these experts available, and so security might even be better. So limited trust in providers. Yeah. Okay. Breaking SLAs. That is, I think, of a big concern, right? So the SLAs, for example, service level agreements. That is a contract you do with a cloud provider. So my application, my servers will run 24 hours all the time. If they fail, what happens? And what happens is you get some free time at Amazon. There is no refund of all the lost business, for example, or any other damage that happened due to the non-availability of the servers. No? So that is definitely a fear. On the other hand, you have higher fault tolerance in the cloud, so so maybe it happens not that frequently as on your own IT infrastructure. Okay, popularity. That is recent statistics from and prediction of Gartner from April 21. It shows you the revenues in the different areas of cloud computing. We see here the infrastructure as a service going up from 59 billion to 106 billion from 2020 to 2022. We also see software as a service here, so it's almost double of the infrastructure as a service, and it goes up also to 145. And we have platform as a service here, which is actually the smallest, the revenues from that, but also going up. So all the numbers basically point in an increase in the revenues from cloud computing. There are also, they distinguish here other areas as well, so business processes as a service and desktop as a service is separate here. We can argue that one or the other falls into the software as a service, but these are, you find these statistics always when you look into how important certain technology is. Go to Gartner and find it, or Statista, you will find similar numbers. History of cloud computing. So it starts, they said it starts with mainframe time sharing here. So not only one program on the mainframe, on the central computer, but multiple running in parallel. Then we have the introduction of ARPANET, so the networking, very important for cloud computing. 1970, virtualization software was launched. 1997, cloud computing as a term was defined by Chelappa. Then in 2006, Amazon started the Elastic Compute Cloud. So that was really the start of cloud computing. And then here you see how the numbers, the revenues from cloud computing actually go up. And it's only until 2014. So you saw the up-to-date numbers on the last slide. So if you want to find out whether you are a cloud provider, you have to ask yourself, do I offer IT service over the network? Yes or no? Is it scalable? So does it scale in the number of customers that I have? And does it also scale for single users? Is it elastic? Is it scalable on demand? Easy and rapid. I mean, it's not sufficient. What I want to say here is it's not sufficient to run a software on a machine that is accessed via network. That's not cloud computing. Yeah, so, and we should be clear about that. Yeah, there is distributed computing in many, many different flavors, peer-to-peer file sharing, for example. All that is not cloud computing. Cloud doesn't mean it's over the network. But it has to have these 5 essential characteristics that I introduced. Yes?
Yeah, I have a question to the slide you showed before, the why going for the cloud,
yeah.
Like with the grid computing and the cluster computing. So those don't really belong to cloud computing? Because that's the opposite of server consolidation, isn't it?
Grid computing and cluster computing are not the opposite of server consolidation. Yeah, so I would say both are different things. So cluster computing is you have clusters for parallel computing, right? And grid computing is you couple these clusters to actually have a sort of service for a virtual supercomputer, let's say. Yeah. So and these basically influence cloud computing. Yeah. Okay. Good. So yeah, be aware. I really want to point this out. Yeah. So we see so many pictures with a cloud, and then you have your computers there. We have also a CAPS cloud, right? So we call it cloud. It's sort of networked, but it's far from being a cloud. So it's only these are resources that you can access over the network, but it's not this dynamic management and so on. All that is not there. This is not cloud computing. Yeah. So we should be precise. Pay per use is important. Was also one of the 5 essential characteristics. So I am a cloud user. I use a service of a cloud provider. Okay, so let's first of all, good if you can answer this with yes. So you are a cloud user. I use Amazon. I require scalability and elasticity. Maybe not. No? So then you could actually run it also on your own server if you put it into your cellar and could run there. You don't need a cloud. So I would say this is not really the idea of a cloud user. Yeah. So then in addition, this is it does not really match here, but a cloud user can also be a cloud provider, right? So that is also possible. So there are companies that offer cloud services, but base these services again on the resources of Amazon, for example. So let me skip this. You might want to go to have a look. So it basically describes what are the trends that actually pushed for cloud computing, that companies want to have cloud computing, and what cloud computing offers here. And yeah, then we are at the summary. So cloud computing as IT as a service, important, no capital investment, pay per use. It comes also with variations, but that is in principle the payment to cost model. Service models we discussed: infrastructure, platform, and software as a service. Deployment models we discussed: the public, the private, and the hybrid, and also this community, but these are the 3 that everybody would name. The major benefits are economy of scale. So you profit from these cloud providers buying lots of hardware, enabling sharing of resources. So you share resources instead of having to over provision resources for your own usage. You divide the work, so you have the responsibilities of the cloud provider to manage the hardware, maybe also the platform, depends on the service model, and then your responsibility will be the application level, and you get elasticity, very important. Yeah, so you can dynamically adapt the required number of resources. So major drawbacks. It relies on the trust into the providers, and I would say that also the interoperability is a big problem. That you are sort of have a login with a certain cloud provider. Okay, any questions so far? Yes, please.
I think you've mentioned that security is an issue with the cloud services, right? But most of the cloud providers these days they provide server-side encryption. So why should security be an issue? Because it's all stored in encrypted format.
Yeah. So if actually really hardware encryption, for example, so you have encryption if you put something into the disks, for example. Yeah. So it's encrypted there. On the way to the disk, it might not be encrypted. So it depends on whether. Someone at the data center would be able to actually access this information. Then there is encryption of the memory content. but that is not available for all the servers. So I think it's more recent technology. So yeah, it's not that common. Yeah.
Amazon has end-to-end encryption,
Yeah, but what means end-to-end?
like even in transit.
Yeah, so if you send something over the network, you can encrypt it. But it has to be encrypted somewhere. Where does this happen? On the network card, maybe? Yeah, what happens between the production of the data and the network card? Yeah, so I agree with you that they do a lot for security, and as I said, in principle I believe that this is maybe even better than what you have on premise, right? Because you don't have this knowledge and maybe also not the tools to enforce security in that strict way, right? Up there was also something here.
Yeah, on slide about infrastructure as a service, you mentioned that it's limited to commodity hardware, but
Yeah.
is it so? Because, for example, Amazon already for a couple of years offers quantum computing options.
Okay, so don't ask me about quantum computing, but yeah, so the whole point of these data centers is that they use commodity hardware. They don't buy the most fancy disk. They buy many standard disks because it's simply cheaper. Yeah, and then they provide a layer on top of that makes it reliable. Yeah, and so that is the whole principle. If you go for high-end hardware, you pay much more. Yeah, it's not proportional to the actually benefits that you have. Yeah, and obviously companies like Amazon, Google, and so on have the money to go into quantum computing. So they might offer this. I think IBM actually is more the company that have it as a cloud service available. Yeah, but that is a different story about quantum computing. Maybe we don't. Yeah, but the principle is really to go for the standard hardware because it's simply cheaper. Yeah. Any other point you want to raise? Okay, if this is not the case, then I think we want to give you a bit information about the exercises. And I have to help you here probably.
Hi everyone. So I'm Anshul. I will be taking your introduction to the exercises or the cloud computing exercises. So before starting, I'll tell you the bit of a history. So we started in around 2017, winter semester, and this is the 6th iteration for this cloud computing exercises. So I hope it is bug-free and without any issues. So before going into the introduction to the exercise, I'll give you a bit of a background about me. So I'm from India. So I did my bachelor's in computer science and engineering from NIT Hamirpur. It's in the north part of India, like somewhere in the Himalayas. And then after doing my bachelor's, I went for the job. I did the software engineering at Samsung, which is mostly about the SSDs, like developing the firmware for the SSDs. And after that, I came to Munich to pursue my master's. So here you can see around 2016, I did my master's here in TUM. I did my master's thesis under Professor Gien. And from there, I got into the cloud computing and everything. And you can see some of the research interests like performance modeling of the microservices. Then recently, we are building this function delivery network, which is the idea of extending the serverless computing to heterogeneous platforms. So we'll see more detail about this into some part of the lecture. So if you need to ask or anything, most probably you should put on the Piazza, and in some cases you can also send me an email also. But on the email, the reply would be slower as compared to the Piazza, so better would be Piazza. And just to point, the Mohawk would be helping me here. So from the next semester, he would be taking over my work. So this is the exercise schedule, so which is inclined with the Moodle. So you can see the first exercise starts next week, and it's mostly after the next exercise would be 2 weeks in time. So except for the first one, which is 3 weeks, so all the next exercises are 2 weeks of time. The first one is given a bit more time because you would be starting new, so we want to give a bit more time for the first exercise. And now to give you a bit more like what this exercise bonus is. So it's, as Professor again mentioned, that it's 0.3. And there are total of 5 exercises, so which covers the various aspects of the lecture. And each exercise contributes to 1 point, so in total you can get 5 points. But to get the bonus, you need to complete at least 4. So like 4 out of 5 you have to complete to get the bonus point. And there are no points for submission or like the partial submission or no submission. So there would be no points. So you have to do a fully successful submission of the exercise to get a single point for that exercise. And the important point, the bonus does not apply to the following grades, which are 1.0, 4.3, 4.7, and 5.0. So it's only if your grade is other than the bonus applies. So I'll now go a bit over the exercise, like the introduction to the exercises. So what these are, what topics we will cover as part of these exercises, and bit of some of the buzzwords which you might hear. So don't get worried about those words. We will give you all the description, everything you know, you will get to know about those words during the exercise session or the lecture. So the first exercise would be the application development using Node.js. So how many of you have already know about Node.js? So that's a good thing. So my job here would be much easier in the explanation. So here the idea with this exercise is that you build a small application using Node.js, and this would be mostly using the, So it would be mostly using like building a web-based front-end application, which would be having a MongoDB attached to it. So over here, as you can see, the users would be sending a request to a front-end, and there would be a backend service, and that backend service would be querying the MongoDB. So as part of this exercise, there would be some kind of a code would be given to you. So you have to see what that code is doing. So you have to modify it so that it works in a certain fashion as required by the exercise to be completed. So it would be much easier for those who has already knowledge of the Node.js, but for those who doesn't have much knowledge, we will give you a bit of a information about Node.js, how you can program it, and some of the code aspects also. So the next exercise is about the accessing the cloud and application deployment using Docker. How many of you have already used Docker or know about Docker? So that's a good number. So here also the job is then much easier. So the idea is now the application which you have built in the first exercise, you would be deploying on the cloud virtual machine using the Docker. So you will containerize the application, deploy on the virtual machine, and see if it is working or not. So here you will be writing a Docker file, pushing the Docker image to the Docker Hub, which is a repository from Docker, and then deploying it. So we'll also learn about a tool which is called as a Docker Compose. So this Docker Compose tool is for running the multiple container application. So yeah, so this is mostly about the Docker. So the next thing, so as these first two exercises are based on a kind of like a monolithic ones, you have everything combined together in a single application. The next exercise is about how you can build a microservices application. So microservices is the idea of splitting the bigger monolithic application into individual services or a small microservice, which then can be deployed on the cloud platform. So here, how many of you have, another question, how many of you have already used a microservice application or built one? So the number has reduced. That's okay. So this is a bit of a diagram of how the microservice application would look like in our exercises. So you would be developing an application which consists of these 4 services, and one of them would be exposed to the outside network so that the user can communicate, and others would be present within the cluster or the virtual machine over here. And the next exercise is the same microservice application deployment using the Kubernetes. So another question, how many of you have used Kubernetes? And how many of you have deployed Kubernetes? So the number is here. So others one, have you used the managed Kubernetes like from the Google Cloud or from the AWS? So whoever used with the AWS and Google Cloud? Very few. Okay. So here as part of this application, we will be first deploying the Kubernetes. So starting from the scratch, how you can deploy the Kubernetes using a single node. And then we will be using a Kubernetes deployment tool like KubeADM. And over here, so we will also explain the Kubernetes architecture, how it functions. So master and the client, how master and the worker nodes, how they interact, how they run the pods and the containers within the cluster itself. And then the application which was developed as part of the exercise 3. So we will be now deploying in this exercise on the Kubernetes cluster created by you. So now we have the application deployed using Kubernetes. So what would be the next one? So last question, how many of you used AWS Lambda? So a bit more number than the Kubernetes. Any other function as a service or serverless platform like Google Cloud Functions? So 1 or 2. That's a good thing. So here we will be using an open source version of them. So if you have heard about OpenWhisk, so OpenWhisk is also available in the IBM Cloud Functions. So if you see the IBM offering as a function as a service, they have the OpenWhisk. So here we will be using OpenWhisk. We will first deploy the OpenWhisk and convert the same application which we deployed or which we created in the exercise 3 into a function as a service based application. So we'll also describe about the OpenWhisk architecture, how it works and everything. So that's the last exercise. And once you have done the exercise on any of these exercise 1 to 5, so how you can submit and how you can do the submission of the exercise. So firstly, these exercises are group based. As you might have seen on the Moodle, there is a choice to choose a group. So how many of you have already chosen a group on the Moodle? So, and it's an optional one, so it's only for those who wanted to participate in the exercises, those can choose the groups on the Moodle. So once you have chosen a group on the Moodle, so then only you can participate in the exercise. And there is a deadline for that, it's 10th of May. So until 10th of May, you have to choose a group on the Moodle. And a group can have only 2 participants, maximum of 2. You can also work alone, with a single participant, but maximum can go to 2. Yeah?
What happens if the person was deregistered from the course,
Mm-hmm.
leave the course, I'm no longer in the course, what happens then?
So the question is if the person deregisters from the course and is not part of the group anymore, right?
Yeah.
So then the other person, which is now the alone, can submit the exercises by themselves. But we cannot change the groups after the deadline. So if it's before deadline, it's good. But after the deadline, you have to work alone then. Another?
So I understood that all the exercises are somehow connected.
Yeah.
So does that mean, for example, if I don't do exercise number 2, I cannot move on to number 3?
Mm-hmm. So the question is, so if all the exercises are connected, so if someone does not do the exercise 2, can that person does not do the exercise 3? So we will provide the code for exercise 2 solution also. So if you don't do the exercise 2, so you will get the solution which you can use in the exercise 3. Any other question until here? Yeah.
What is how much time do I need for the exercise if I've never programmed anything on Node.js or any of the other things before?
So the question is how much time does require to do the first exercise, which is based on Node.js. So as part of the first exercise, we will be giving 70% of the code. So 30% of the code of that exercise would be missing. So you would have to learn a bit of, so if you have knowledge of any programming language, Node.js is quite easy. So you can easily work around with that. So it should not take more than a week, I would say. Which will like you have 2 to 3 weeks for doing that, so it should not take more than a week. Yeah. So the question is, if I understood, is that you can submit the solution, or should I release the code for the solution? Yeah.
The first one is like the of May, the second one is like first of June.
Yeah.
But if I had the chance, I'd like to start the second project earlier than the first.
So the question is, if someone wants to start the second exercise before the deadline or the start date of the exercise, you cannot do, because the exercise and the code description or everything would be released on that particular date only, once the first exercise or the previous exercise is finished. Any other question? So the next part is where to run these exercises, or how you can test your exercise. So as part of our lecture, so you can use any cloud provider. So we don't have any inclination towards AWS, Google Cloud, or Azure, depending on which credits do you have. So like for AWS, you can create a student account using this link, which is on the exercise or which is on the presentation. And for the Google Cloud, there are 2 links. One is for the students, and the other is for like if you can add your credit card, so then you can get around $350 free credits. And the third option is, which we are waiting from the Google Cloud. Usually they sponsor these exercises. I think from last 2 years, they are giving the credits. So I'm quite positive you will get also that. So then you would have to just click on the link which is provided by the Google Cloud, and then you can use their cloud as well over there for solving the exercises. So I will put the link on the Moodle, so once I have the link. And for submission, all the exercises are checked automatically, are corrected automatically. So after you run an exercise, so you would have to submit in a particular fashion, which I will describe in more details for each exercise, depending on how you can submit the solution for that exercise. Yeah? Uh-huh. So the question is, can you check if the solution is correct or not? Yes, you can check the solution by submitting to the submission server. There you can put the solution and see if you have a successful submission or a failure. So you will also get a reason why it is failed, so that you can do the debugging part also.
So you can submit multiple times?
Yes. So the question is whether you can submit multiple times. Yes, you can do the multiple submissions. So there is until the deadline part. And the submissions are done using the server, which you can see the link over here, which I will also put on the Moodle. And the credentials for logging inside the server will be based on the group, and I will put them on the Moodle for each group, and then only you can log in inside this server and do the submission. And you will get the credentials on the Moodle, as I mentioned earlier. And more about the submission I will explain during the first exercise next week. Any questions? Yeah. I didn't understand. Can you say it? Okay, so there is a bonus point transfer to the.
It only works for the normal exam.
So the bonus is not transferred; it only works for the normal exam. Yeah.
Regarding the exam, is the exam based more on the lecture or more on the exercise? Like, do we need the exercises for the exam?
Yes, you need both.
So the question is whether the exam would be based only on the lecture or on the exercise. It's both. Any last questions or something? So if you have any questions, please put on the piazza so that me or Mohab can answer over there.
Okay, then see you next week. Goodbye.
That's all. Just like